Hello my dear friends, welcome all of you to Yourpedia and Engineers Career Point. So my dear friends, today we will discuss the most important question of machine design with respect to if you talk about BEL exam. So my dear friends, in the last time when exam was conducted, if you talk about the weightage of machine design, so directly 14 question one from the machine design, 14 questions, and 2 question was from the indirectly, there the need of machine design or you can say the concept of machine design involved. So in fact we can say 16 question has been asked from the machine design. So you can understand for the BEL how much important subject this is, right? So that's why we have come with the whole syllabus machine design. There we can check your the preparation level, and you can enhance your concept if anything is lag is there, right? So today we will discuss top question, and or that all are the that question that directly you can find in the exam. In our BEL course you have already completed the machine design, right? So for those guys you will find very safe yourself. Still you are getting any lag of your concept, don't hesitate to convey us in the group. You can message me directly or you can message in the group also. We will take your doubt whatever you have. Okay, so my dear friends, your time is important, so without wasting any single instant, let's start with the question. So that is the first question on your screen, my dear friends. The question is that a stress concentration is caused due to, why stress concentration is coming, and option A is variation of variation in load acting on a member, variation in the property of a material in a member, abrupt change in the cross section, and option D is all of the above. So what is the correct answer, my dear friends? So what is stress concentration? I always used to define the stress concentration. The main purpose of the stress concentration is the sudden change of the profile of any object. Like suppose that is the body, right? If I will ask, I am going to apply the load F, let's assume. I will ask what is the theoretical stress. So we can say, sir, stress is equal to force upon area, right? That is the theoretical stress. Well, theoretical. Okay. Now what I am going to do, let us make any change, something like that. You are going to be cut the material from that section. Let's assume you are going to cut the material that section. Now that is the new section. Now that is the new section, my dear friends. So what is happening? We can say that is the stress that you are going to get the theoretical question, theoretically stress. But if you talk about here, so in this is what is happening, my dear friends, stress is not same, it is going to be changed. Why? Because the sudden area it changes, right? Whenever profile it changes, the stress is going to be concentrated here, right? So that is called is what? Stress concentration. Sometimes in the class I used to give the example. Suppose that this is one of the body, and that is their cross section, and you are going to apply the force F, right? Now I will ask, if the body will fail, so from which section that body can fail. Let's assume that is a section A, that is the B, that is the C. I will ask, if the body will fail, then from which point it can fail? Obviously we can say it will fail from the point B if it is going to fail. Now the question is why it will fail from the form B. So you can say, sir, if you are going to be calculate the stress is here, you can say stress is force upon area, that is the theoretical stress. But my dear friends, here if you coming to the section B, there is a sudden change in the profile. Due to the sudden change in profile, what is happening? Stress is going to be concentrated here. Stress is going to be concentrated here, right? And that value is more than that. That's why the body will fail from that section. So the question, stress concentration is mainly caused due to, so the correct answer is what, my dear friends? C for Chennai, abrupt change of the cross section. Because of that, stress concentration is going to be takes place. Another thing you can understand, stress concentration, basically that is the, what is the value of stress concentration? If you talk about stress concentration, so this is given about sigma maximum, which is actually developed upon, we can say sigma theoretical, that you are going to be calculate the theoretically. So that is called your stress concentration, right? So Chennai is the right answer. Come to the next question, my dear friends, and I will share that PDF in the group, right? I will share that PDF in our group. From there you can able to download that. So here everything that I have told you here, you can see now, defined as the localized of high stress due to the irregularities present in the component and abrupt change of the cross section. So Chennai is the right answer. I will share that PDF, don't worry. Now that is the next question. Question is that indolence limit or a fatigue limit. Which limit, my dear friends? Indolence limit or a fatigue limit is a maximum stress that a member can withstand for an infinite number of load, or you can say infinite number of cycle, infinite number of load application without failure when subjected to dynamic load, static load, combined statics and dynamics load, and completely reverse bending. So what can be answer, my dear friends? You know, here you talk about the endurance limit, right? Endurance limit, or you can say the fatigue limit, is the maximum stress that a member can withstand. So what is endurance or fatigue? So you can see endurance and fatigue limit is that, sir, in which a member can withstand or can sustain for an infinite number of cycle for a given load, and that is called is what, my dear friends? Endurance limit. Now the question is that for which load, sir? Endurance limit is defined for the fatigue load, no problem. But my question is that, sir, fatigue load is 4 types, sir. It is fluctuating load, it is repeated load, it is cyclic load, right? So which of these? So maximum or endurance limit is always defined for, my dear friends, completely reverse load. Why? If you talk about the fatigue load, I will ask there are 4 types of fatigue load. Which one is most dangerous load? Then the question is that, sir, completely reverse load is the most dangerous load. That's why if you are going to be save anybody in a very critical situation, then in the general situation or normal things, they will work properly. That's why endurance limit or fatigue limit basically going to define with respect to the completely reverse load. What do you mean by completely reverse load? Let's, my dear friends, suppose that is the body on which I am going to apply plus minus 50 Newton, plus minus 50 Newton. That means at t equal to 1 second, the load is plus 50 Newton, that is tension. After t equal to, let's assume 10 seconds, the load is now minus 50 Newton, that is compression. So tension, compression, tension, compression, tension, compression, and magnitude is same, my dear friends. So if due to that what is happening, there can be the crack inside the body, sudden compression expansion, compression expansion. Due to that, there will be the crack formation in the body. Once the crack will form, they will propagate, and once the crack will propagate from end to end, the body will get fracture, or it is going to break down or going to be failure. So my dear friends, you can say that load is called is what? Completely reverse loading. For that you are going to define the endurance or fatigue limit. Come to the next question. Okay, just I want to ask one question with you guys. Suppose if you have to be increase the endurance limit, then what we can do? Suppose I will ask you, you have to be increase the endurance limit. What option you have? 2 things you can do, my dear friends. 3 things basically to improve the life of body under the fatigue load. 3 things is there. 1, make a body smooth. You can make a body smoother. Second thing, we can do the you can reduce the size of object. You can reduce. And third thing is one approach is known as a short pinning process. By these 3 ways, we can increase the life of the any member under fatigue load. Try to remember. Next question, notch sensitivity varies from, and that all are the option. So notch sensitivity, my dear friends, please try to keep in mind, always going to vary 0 to 1. Notch sensitivity is always going to vary 0 to 1. Try to remember that value. Here we can say notch sensitivity is given by, try to remember that formula also, because sometimes you will find the numerical, and that is a very easy numerical. They will going to give the value kf, kt, and they will ask what is the stress concern, what is the we can say what notch sensitivity. They will ask. So try to remember. Kf is called actual or fatigue stress concentration. Kt is called theoretical or stress concentration factor, and that value is going to be lies between 0 to 1. In fact, they will take the value 0 also. When Kf is equal to 1, let's assume when Kf is equal to 1, then what will be Q, my dear friends? It will be 0, right? So it will be going to vary between 0 to 1. Try to remember that point, and try to remember that formula also, my dear friends, because question we can directly they can ask on that formula to calculate the stress concentration factor. So it is advisable, try to remember that formula. Next question, a cotter joint is used to connect 2 rods which are in compression only, tension and compression, tension or shear only. Cotter joint is what, my dear friends? Simply suppose this is one of the shaft, this is another shaft. Okay, now insert them in that, and after that put one pulley like that. Suppose that is the hole. Okay, that is the another shaft that you are going to be insert that, and after that you are going to be put here one pulley which will inserted from these 2. So this pulley will be called is what, my dear friends? Cotter. Are you getting my point or no? Suppose 2 shaft is there now. Let's assume this is one of the shaft, or let's assume little bit hole is there, and this shaft is going in the hole. Let's assume this is the hole. Now after that, this is the shaft which is rotating, that is the another shaft where you have to transmit the power. After that, you are going to use one cotter. Up here it will be hole on that, use the cotter, and here, so these two will be connected and power will be get transmitted. So now the question is that, my dear friends, cotter joint are used to connect two rods which are in compression only, tension on compression, tension or shear only. So my dear friends, cotter you can use either in the tension or compression. In both the case you can use the cotter joint. So Bombay is the right answer, my dear friends. B for Bombay is the right answer. You can see here, no? Directly we can see here, no problem in that question. Okay, come to the next question. When shafts are slightly misaligned, then the most suitable coupling to connect them. So if the shafts are misaligned, means two shafts are misaligned, my dear friends. Suppose this is one of the shaft and this is another shaft. Let's assume you have two shafts, my dear friends. This is one of the shaft, this is another shaft, right? And they are going to be, if they are like that, then completely aligned, no problem is there. But they are misaligned like that. These shafts are misaligned. In such case, which type of coupling is going to use? My dear friends, I usually used to say in the class, there are two types of coupling if you talk about. One is called flexible, another one is called rigid coupling. First is called flexible, another one is called rigid coupling. If you talk about rigid coupling, my dear friends, when two shafts are coaxial, then you are going to use the rigid coupling. From the name itself indicate rigid. If you talk about flexible coupling, then these two shafts are either laterally or some at angle like that. In such case, you are going to use the flexible coupling. So in the question very clearly mentioned that shafts are what, my dear friends? Slightly misaligned, means they are not going to be aligned, that are misaligned. For the misaligned, you are going to use the what, my dear friends? Flexible coupling you are going to be used. So correct answer is what, my dear friends? Before Bombay. Try to be remember. Here you can see classification of coupling. So one is rigid coupling, another one is flexible coupling. If you talk about rigid coupling types, muff coupling, slit muff coupling, flange rigid coupling. If you talk about flexible coupling, so it will be boost, Oldham coupling or universal coupling comes under the category of flexible coupling, right? So here we can say when the shafts are slightly misaligned, then the most suitable coupling to connect them is flexible coupling. Okay, not slightly misaligned, then the most suitable coupling connect to is what? Rigid coupling. So try to remember that question, very easily going to be asked. Okay, in the classroom I have discussed all that in the very details. So go through that one also. Try to remember when the Oldham coupling, when the universal coupling, when the which coupling is going to be used in which circumstances. That is the next question from the key. The question is that a key is preferred for the condition where large amount of impact torque is to be transmitted in both the direction. What is the key word of that question, my dear friends? The key word of that question, both the direction. That is the key word. So which of the key which can transmit the power in both of the direction, right? Which prefer to condition where the large amount of impact torque is to be transmitted. Impact torque and their value is large in both the direction. For that, my dear friends, you are going to use the tangent key. In tangent key, basically there are two keys that will be at the 90 degree, right? Like that. One key is there. Let's assume one key is there, then another will be there, and their angle will be the 90 degree. So two keys, so they can transmit power in the two direction, and that's why it is called tangent key. One more thing, my dear friends, another key is Kennedy key is also there. Kennedy key, in Kennedy key also the two key at 90 degree. But in the Kennedy key, the condition is that the key that you are going to use, that must be squared. So only one difference between the tangent key and Kennedy key. Try to keep in mind. In tangent key, that key can be any cross section. It can be circular, can be rectangular, can be anything, right? Can be tapered. But if you talk about, my dear friends, Kennedy key, in that Kennedy key what is happening, that will be at the 90 degree, but the cross section of key must be square. That is the major differences. So sometimes in the option, rather than tangent key, they use the Kennedy key also. So you can go through that, no problem is there, my dear friends. Correct? Okay, well, come to the next question. So here you can see the same that I have told you. Next, the type of joint used in cycle chain. Which type of joint is going to used in cycle chain? Quarter joint, knuckle joint, Gibbs and quarter joint, or riveted joint? My dear friends, what will be the cycle? Quarter joint, you know, okay, sometimes you know, no, my dear friends, if you don't know the exact answer, what we can do, you can eliminate the option. I usually used to say in the class, my dear friends, sometimes if you have go through your whole syllabus, but you don't know the exact answer of the question, in that case, you can eliminate the option also. Like quarter, no sir, cycle you have seen, quarter joint is not going to use, sir. Just now you have seen, sir, like that. After that, you are going to use that. So quarter is that. So quarter is not going to be used. Okay. Sir, riveted joint. Sir, riveting is there in the cycle chain. No, sir, that can't be, sir. Gibbs and quarter. Sir, quarter is here also. It can't be, sir. So what should be, sir? Only should be the knuckle joint. So in the cycle chain, the joint is what, my dear friends? Knuckle joint. In all the chain, basically joint is what? Knuckle joint. So try to remember and note in the class. In the class, I mostly used to say that sometimes. If you have go throughout your syllabus, you have knowledge. You have good knowledge of your subject, but the thing is that option, and you are going to forget in the, because you know in the exam real situation is there, some question you haven't solved, you get the hypothetical pressure on yourself, and after that you are not going to give your best. So in that case you can eliminate the option also. Quarter can't be, Gibbs and quarter can't be. Riveted, sir, rivet means skill, na? So riveted can't be, na, sir. So the correct answer is what? Knuckle joint. So by that way also you could be able to remember the question answer. Okay, my dear friends. Next, which of the following key transmit power in a taper shaft? Which of the following key transmit power in a taper shaft? Birth key, Woodruff key, Kennedy key, or tangent key? You know, sir. Birth key, Kennedy key, tangent key. Tapered, na, sir. Taper shaft. For the taper shaft, generally Woodruff key is going to be preferred. So that is the question of the shaft keys and coupling. From that topic, that question has been taken, and we can say what? Woodruff key. It will be something tapered. Woodruff key is what? Tapered. What is the taperedness? So 1:40. Try to be remember 1:40. That is the tapered. Okay. So that is the next question. The key will fail in which of the following manner? Key will fail in which of the following manner? So tell me the answer, my dear friends. Key is going to fail in which manner? That is the answer. Shearing only, cursing only, both shearing and cursing, none of these. So key will fail which of the following manner? Shearing only, or you can say the cursing only, or both shearing and cursing. My dear friends, key can fail because of both shearing and cursing, right? Key can fail because of both shearing and cursing. So correct answer is what, my dear friends? Chennai. So sometimes in the exam they will ask the formula of shearing and cursing. So try to remember that one also, my dear friends. But here it can be fail because of the shearing and cursing. How many types of keys, my dear friends? How many types of keys are there? Anyone have remember? Huh? How many types of key? Please comment in the comment in chat box. How many types of keys are there? In which friction is more important, and in which friction is more important, right? Or by which friction is mainly responsible for transmit of, you can say, the power. Next, the efficiency of a screw jack is maximum when? That is the formula has been asked in all the exam. If you go through any exam previous year question, you will find that question, my dear friends. So that is such a more important, and try to be remember in a screw jack, if you get the maximum, if you want to get the efficiency of a screw jack is maximum when phi is equal to 45 degree minus of 5/2. So that is called helix angle. Alpha is here helix angle. So I have came with the derivation also to you guys. Okay, efficiency screw jack is given by 10 alpha upon 10 alpha plus phi, and after that just you are going to be integrate, and after differentiate, and after that you will get the relation phi equal to 45 minus 5/2 alpha is equal to. To try to remember that result directly, it will be helpful you in the exam. Next question, which of the following power screw transmit power in one direction only? Power screw. transmit power in one direction only? That is the next question, my dear friends. So what could be the answer, my dear friends? Anybody? A screw jack you might have seen, whenever suppose your you are running your four vehicle, okay, sometimes their tire is get punctured and you are going to the mechanic shop, so they will use the power screw to lift your car. So one direction means what? They are going to be like that. Okay, you have just rotated like that. Meanwhile, your power screw is going to be up. Now, so if the two direction is there, what can be? You are just revolve, it goes up, and after that it will come down. So in that, mainly it is going to prefer the you can say the one direction only. Like you have just rotated by one. If you are stopped, again this will be in the static condition. They will not going to be reciprocate. Again you are going to revolve that one. Again it is going to be up like that. So for that, which one power screw is going to be used? So that will be the buttress. In that you are going to use the buttress thread. Basically various types of thread is there. Acme thread, can anybody tell me what is the included angle in the acme thread? What is the included angle in the trapezoidal thread? That question can also be asked, my dear friends. So from a single question, try to learn all the things. So and you have to make a comment, my dear friends. In the class you have discussed all that. Let us check your knowledge. In buttress, what is the included angle? You have to be comment. In acme thread, what is the included angle? In the trapezoidal thread, what is the included angle? In the square thread, obviously you know. So you have to be comment all that included angle. At that is important. You have to be keep in the mind in the main exam. Okay, you can see here buttress thread. Okay. Wait, that is the next question. One question is left in between, I think so. So in the question you have given that angle, they will ask to calculate the maximum efficiency. Try to remember that formula for the maximum efficiency, my dear friends. Try to remember maximum efficiency given by 1 minus sin phi upon 1 plus sin phi. Actually that question is miss, might be. So here phi was given and they were asked to calculate the maximum efficiency. Next question. On the triple start thread screw is equal to what? Option A, lead equal to pitch. Option B, lead equal to 3 pitch. Option C, 9, lead equal to half of pitch. And option D, lead equal to 9 times of pitch. So what can be answer, my dear friends? Anybody? What can be answer? Tell me fast. You are going to be talk about what, my dear friends? Triple start thread, right? What do you mean by triple start thread? So if you talk about triple start thread, basically, my dear friends, if you talk about thread, so that are two types, single start or multi start, right? Single start or multi start. Single start thread means if you are going to be rotate by 360 degree, they will go one pitch. They will, you just assume in your mind nut and bolt. Let's assume in your mind nut and bolt. Just assume, try to visualize the things. So if you are going to be remove the nut by 360 degree, so whatever axial distance they will be traveled by, that is called lead. What is called lead, my dear friends? Whenever nut and bolt is there, nut, you revolve the nut by 360 degree. So whatever axial distance traveled by the nut, this is called lead. In single start thread, they will travel the one pitch distance. What is the one pitch, my dear friends? So suppose if you talk about any thread like that, so the gap between this and this is called one pitch, my dear friends. This is called one pitch. So if the distance traveled is one pitch, basically the gap between two consecutive thread is called one pitch, my dear friends. You can understand for your analysis. So on single start thread, by one revolution they will move one pitch, and always try to keep in mind single start thread generally going to use for the fastening purpose, to making a joint. For that you are going to use the single start thread. What is the meaning of multi start thread? The multi start thread means basically if you are going to revolve your nut By 360, they are going to move more than one pitch. It can be 2 pitch, it can be 3 pitch, it can be 4 pitch, it can be 5 pitch. That is called is what? Multi-start thread. Means in one revolution of nut, they will travel more than one pitch of axial distance. That is called multi-start thread. In 3 start pitch means in one revolution they will move the 3 pitch distance. That is called is what? Multi-start thread. And multi-start thread generally preferred for the power transmission. Multi-start thread basically going to be the fast power transmission, like sometimes in the shop you can see the shopkeeper uses here the multi-start thread is there. Shutter, shopkeeper shutter you might have seen now, you are going to rotate that and shutter is coming up and down. So here multi-start thread is there. So in the question triple, so it will be the lead equal to 3 pitch. So B for Bombay is the right answer. And pitch, so when you can say triple means 3, double start means 2, like that. That is the next question. The motion of the nut on a threaded bolt is helical, plane, spherical, or none of these. So what is the motion of nut on the threaded bolt? Obviously you can say, sir, it is moved like that, na sir? So that is what, sir? Helical, na sir? Are you getting or not getting here? Like that, na? That is. So this path, even you can say the thread is what? Helical thread, na yaar? So the correct answer will be what, my dear friends? B for Bombay is the what, my dear friends? Right answer, okay? Sorry, B for Bombay nahi, A for apple. A for apple, helical, na? Plane is not there. So because you know threaded is itself a helical, so path followed will be the helical. So correct answer is what, my dear friends? A for apple is the right answer. So that is the next question. A universal joint allow the propeller shaft to. Universal joint allow the propeller shaft to. Option A, bend sideways, change length, transfer torque at an angle, change inclination. So universal joint you talk about allow the propeller shaft to allow the propeller shaft to transfer torque at an angle. Even they can transmit the torque at some angle also. Suppose what is the meaning of that, sir? Please try to elaborate practically. Suppose this is one of the shafts. Okay, yeah, I can catch you well. So that is one of the shaft, that is another shaft. These two shafts are at some angle. You can see here. These two shafts are some at an angle, like that power. In that these are inclined to another, no? So in that way we can use the universal joint to transmit the power, That see, this is the horizontal shaft and this is like that, So or sometimes it could be like that also. It could be like that also. In such case also you can use that one, So try to remember that point, my dear friends. Important it is. So correct answer is what, my dear friends? C for Chennai is the right answer. Next, railway carriage coupling have a square thread, acme thread, knuckle joint and buttress thread. So what could be answer, my dear friends? Railway carriage coupling have which type of joint? So we can say the railway coupling, carriage coupling basically have the knuckle thread, which is use what? Knuckle thread. So C for Chennai is the right answer. Have knuckle thread. Next question. In a steam engine, the valve rod is connected to an eccentric load by means of what could be the answer, my dear friends? In a steam engine, the valve rod is connected to the eccentric load by means of. So the correct answer is what, my dear friends? That will be the knuckle joint. Eccentric, no? Quarter is going to use, there is no any eccentricity, Quarter, you cannot use the whenever the eccentricity is there. Eccentricity means center to center gap is called your eccentricity, na? So A can't be. The correct answer is what, my dear friends? Before Bombay. Knuckle joint is a mechanical joint used to connect two rods which are under a tensile load. So in a steam engine, the valve is connected to an eccentric load by means of knuckle joint because withstand tensile load. Next question. The transverse fillet weld joint are designed for. The transverse fillet weld is designed for that is the question. A transverse fillet weld joint are designed for tensile strength, bending strength, shear strength, sorry, shear strength or compressive strength. Transverse fillet weld, why it is going to be designed? Tensile strength, bending, shear, or you can say the compressive strength. So when transverse fillet is basically designed for the tensile strength. Transverse fillet, you know my dear friends, how you can make a transverse fillet joint. If you talk about how you can make transverse fillet, these two are interconnected like that, like that, okay, and you have welded here and the force is like that, then this is called transverse fillet, and basically this is going to design for the tensile strength. We can see here the formula is also there, try to be remember. Numerical can be asked from that one, but since calculator is not there now, so point less chances to ask the numerical. Next question, the ratio of rivet hole to the pitch of rivet is 0.25, then the tearing efficiency of the joint is. So that is the question has been taken from the riveted joint. So in the class I have told you a riveted joint and rivet, two are the different things. Riveted joint, suppose these two and you have put the nut here, then it will be called riveted joint, and this is not involved in the joint, then this is called rivet. And these two, after that you are going to do the riveting here, means kill thoko like that, then it will be called is what, riveted joint. So my difference, rivet can fail by two ways. One is called rivet can fail by cursing or shearing, and the plate over which you are going to make the riveting, that can fail because of the tearing. So riveted joint can fail in the three ways. Just listen: cursing, shearing and tearing. But if you talk about rivet, so rivet can fail in two ways, by cursing and shearing. The plate can fail because of tearing. So these are the three ways by which you talk about the riveted joint can fail. Riveted joint means when they are involved to making a joint, then it will call riveted joint. But when it is not involved, like that only, like that is there, then it will be called is what, rivet. So in the question you have to be calculate the tearing efficiency, my dear friends. You have to be remember that formula. Very frequently it is going to be asked. Here I have given with the formula, try to be remember. The formula is D upon P is given. Tearing efficiency is P minus D upon P. So PP will be get cancelled out. So tearing efficiency you talk about, that is 1 minus D upon P, and the tearing efficiency is equal to 1 minus 0.25. By solving that you will get the 0.75. So tearing efficiency is how much? Got option 0.75 is the right answer. If they will ask the percentage, it will be 75%. Next question, caulking and fulling process are used as to lubricate the bearing, to reduce the friction between matting part of gear, to obtain the self-locking screw, to obtain the leak-proof riveted joint, to cool the bearing. So caulking and fulling, you know my dear friends, whenever you talk about the riveting, so riveting have one of the biggest drawback, that they have a chances of leakage. And whenever if you want to be their application where huge amount of pressure is there, or the fluid is going to be passed at a higher pressure, then it's not good to use the riveted joint because of the problem of the leakage, right? So to reduce that chances, to reduce that leakage, to overcome that leakage issue, I am going to use the caulking and fullering. So caulking and fullering is the process by which you can make a riveted joint leak proof, and after that it can be used for the where high fluid pressure is there it can be also be worked. That's why my difference we can say caulking and fulling is you are going to use the obtain the leak proof riveted joint, and the correct answer is what, my difference, D for Delhi is the correct answer. So try to be remember why caulking and fulling is going to be used. That is caulking and fulling. That is the next point. In a riveted joint, when number of rivet decreases from the innermost row to outermost row, then the joint is said to be chain riveted, zigzag riveted, diamond riveted, or none of these. So what can be answer, my dear friends? Please tell you fast. What can be the answer? So repeated joint when the number of repeat decreases from the innermost row to outermost row, and that is called is what, my dear friends? Diamond repeating. That is called is what? Diamond, because here shape of the repeating becomes like a diamond shape. That's why it is called diamond repeating, because of the shape becomes something like a diamond. Is any diagram I have? Let me check. You can see here. This is the repeating. So it looks like something like a diamond shape. That's why it is called is what? Diamond repeating. So that question you have to remember. Various times you will find the question on the diamond repeating. So try to be remember that question also. Now, aircraft body is usually fabricated by welding, precasting, riveting, or we can say the casting. So, if you talk about aircraft body, you might have seen in the wings of aircraft, lot of riveting has been done. Anybody can tell me? Okay, you can say the answer. Sir, riveting is the aircraft body usually fabricated by the riveting. But my question to you guys, why? Why on the wings or everywhere we can see the riveting is going to be used in the aeroplane? What is the purpose? You have to be make the comment, and if your answer is wrong, no problem, I will give the answer in your comment also. Otherwise, when we will meet in the next session with some another question of the machine design, whatever topic is left, then I will give the answer. But yes, before that you have to be put your message, you have to be give your comment about that question in the chat box, then we will see how much you are close to the correct answer. So aircraft body is usually fabricated by riveting, but my question is why, you have to be answered. Thank you. Come to the next question. Okay, that is the question. A plate is connected to a column by a 4 rivet carries load P. If the center of the rivet form the square, and if they are designed on the basis of shear stress, then the load carries by, and that diagram is present in the question, my dear friends. The rivet A and B is maximum, the rivet A and D is maximum, the rivet B and C is maximum, rivet C and D is maximum. So what can be answer, my dear friends? Anybody? What could be the answer? Tell me fast, waiting for your answer. My dear friends, just try to remember one conclusion. I am not going to prove here, because not going to prove, but just try to remember one conclusion. The conclusion is that the rivet which are close to the applied load, any rivet which are closer to the applied load will have maximum stress will get generated over that. So we can say, if you talk about A, B, C, D. So sir, if I will talk, which one is the rivet close to the load? Send B and C, na sir, B and C, or you can say C and B. So the correct answer will be C4 Chennai. And why it is, sir? I will prove by taking some example. Even you can directly do that. But here just try to remember one important conclusion. The rivet which are closer to the load will have maximum stress, and even if you have to design the rivet, you have to be, if this rivet is safe, that A and B will be itself safe, because maximum load is going to be generated on B and C. So try to remember that question various times, that is also going to be asked. Next question, what is the diameter of butt joint if the thickness of plate is 25 mm? What is the diameter of butt joint? So in the question nothing data is given, so sometimes a student think, sir, and that question data is insufficient, how I can do that, because nothing is there, sir. Diameter of bolt joint is going to be asked, even the plate thickness is known. So how I can do that, sir? My dear friends, in such case, if nothing is present in the question, try to use the unwind formula. According to unwind formula, D equal to 6 root under T. D is equal to dia is equal to 6 root under T. In the question, 6 point something is coming, but since 6.0 something is coming, but since calculator is not na, so directly I can use 6 root under 25, obviously we will get 30. So the correct answer is what, my dear friends? D. So in that question, if nothing is given, in such case, my dear friends, you have to use the unwind formula, that is equal to 6 root under T approximate, we can say, and we will get the answer. Next question, snap head rivet are used in. Snap head rivet. So rivet are various types, out of which one is what? Snap rivet. So when snap rivet are used in, when the snap rivet is going to be used, that is the question. Tell me, anybody? Snap head rivet are used in, even it can be used in the aircraft body, shipbuilding, structural work, in all that you are going to use the snap head. So correct answer will be D for Delhi, all of the above. Snap head rivet are going to used even in the aircraft body, even in the shipbuilding, some structural work, means in the building of the bridges also, in that snap head. So you can say the D for Delhi is the right answer, all are going to be used. Snap head is like that, na? That is the, you have to just remember D, then that head will be 1.6 D and that will be 0.7 D. Sometimes, very rarely, that thing is going to be asked on the design. That is the next question from the clutch, and that is an easy question. I know everyone can do that. In a multiple disc clutch, N1 is the number of disc on the driving shaft and N2 is the number of disc on the driven shaft. The number of pairs in the contact surface is given by, so N effective is given by, if you have remember, N1 plus N2 minus 1. N1 plus N2 minus 1. So correct answer is what, my difference? C4 Chennai is the right answer. Effective number of pairs N1 plus N2 minus 1. If the load of the ball bearing is half, then its life. So that is the question has been taken from the bearing, and that question has been asked several times, my dear friends. Several means several times. In all the exams, that type of question has been asked. So anybody can give the answer of that one? Tell me first. Can you do that? Waiting, even in the class you have did that question, if you have remember. So in the class you have completed that type of question. Na? So what answer you are going to be get, my dear friends? Ball bearing. Na? Try to remember that formula. Life of ball bearing is given by L equal to C by P ke power 3, or sometimes it will be N instead of ball bearing. In case of roller bearing, actually life is given by C by P ke power N for all, not even for the roller. This is given by. But if you talk about roller bearings, in the roller, what is happening, my dear friends? Simply na, N is equal to 10 by 3. But that is the, because without calculative 10 by 10 upon 3 means 3.33. So it will be very calculative. Impact student can't solve. Na? That's why they are going to ask about the ball bearing. In case of ball bearing, N is equal to, it is coming out to be 3. So here simply we can say, sir, L is the life of bearing, P is the load, and C is called dynamic capacity simply. So L equal to C upon P ke power 3. By using that, load has been half, so life will increases by 8 times. So try to be remember that relation. You will find one question, sometimes numerical data, instead of, suppose L1 is given, let's assume 1000, let's assume meaning 1000 hour, anything is there, or RPM, whatever. So they will ask what will be the L2 like that. So you have to be answered 8000 it will be. So like that option is also going to be framed. So try to be remember that things. A starting friction is low in hydrodynamic lubrication, hydrostatics, hydrodynamic, mixed, or starting friction is low, in which case the starting friction will be the least, or sometimes we can say the low. In which case hydrostatics lubrication, hydrodynamic, mixed, or bonded lubrication. My dear friends, a starting friction. So hydrostatics, if you have remember, in which it will be the minimum, it will be the hydrostatics, because if you talk about hydrodynamics, what is happening? This is just I am going to see you cross section. So there will be the metal to metal contact in the hydrodynamic, right? So at the metal to metal contact, which friction can be there? Like that. If you want to their side views, it will be something like that. That is the another, na? So it will be the contact here. That is their cross section view. If you talk about the hydrostatics bearing, so that is the bearing, and in that what is you are going to be supply? You are supplying the fluid at a high pressure. You are supplying the fluid at a high pressure, and because of that fluid there is no any metal to metal contact. Even they can Even in the statics condition, there is no any metal to metal contact, so no friction, so very easy to starting, or you can say the very least starting friction. So A is the right answer. Rest difference you have to be give. That hydrodynamics generally going to be preferred at a high RPM, hence they will rotate at a very high RPM, then only here the lubricant is there, that lubricant will come, and due to that lubricant the pressure is getting increases, and might be possible the contact is going to be disengaged. But in the hydrostatics, even at the lower RPM or even at the statics condition, there is no any metal to metal contact, so no friction, or it is easy to start also. So my dear friends, sometimes you can say here starting torque is less, here starting torque is needed high because of the metal to metal contact. So all that differences is there that you have to be just keep in mind. But one more thing, here less lubricant, but here lubricant will be the high, more lubricant will be there, so cost will be the high. Petrov equation used to find out. When you are going to use the Petrov equation, my dear friends, when you are going to use the Petrov equation, so Petrov equation is going to find frictional loss in the bearing. The function of Petrov equation to find the frictional loss in the bearing. How much bearing in this bearing friction loss is going to be takes place, that you can find through the Petrov equation. Here that equation is there, you can even remember if you want. Ball bearing is usually made from, ball bearing is usually made from, ball bearing is going to be made by the chrome steel. Okay my dear friends, it is going to be made by the chrome steel. So that all are the questions that we have discussed. In the another session when we will meet, we'll see the some more important question with respect to BEL. You have a time, you can, no, you have a time my dear friends, because your exam is tentative in the mind, tentative, that's not sure, but that's why you have a time. If you haven't started your preparation till now, please start preparation. And because you know in that preparation obviously you need a guide, because which type of question is there going to be asked. So Yourpedia and ECP team is there to help you out. We can join here, and all the things we have completed here in the details, so we can go through that. And yes my dear friends, currently your BHEL exam is also coming, so focus on that one also. We are our numerical practice session is going on, so you can join all that. Okay. So my dear friends, thank you all of you. We'll meet in the some other session with some important concept. Thank you, and yes, good luck.